Hello, everyone. Now we will begin with the Java fundamentals from the very fundamentals, and then we continue with the basic syntax of it. And our motto in this lecture is anyone can code with this. I don't know if you watched this movie. So if you had a bad grade in the previous course, that is fine. Now we are, if it is the case, no worries. Inshallah, we'll see that anyone can code. We will, inshallah, see it this dream. So what we will see is some basic stuff with the Java. So what is Java? Java is a class-based, general-purpose, object-oriented programming language. So now you will have this challenge this semester all the time. You first learn Python. Now you are using Java. And they have so many common points, but also from a syntax perspective, they have differences. So it will be a challenge for you not to confuse the syntax of Python with the Java. Time to time, I will say that, okay, in Python you do this, but in Java we don't do it. We do it in that way also, okay? Some valid statements in Python are invalid in Java. So this will be a challenge for you, especially during the exams, because when you are writing on a computer, the computer will immediately warn you that you cannot do it. But in the exam, you won't have that chance. So to better study, I highly recommend at least some part of your study, do it on the paper or do it on a notepad that doesn't immediately provide you a feedback about it. So that will be a more better environment for your study. Now, it is developed in 1995, then Oracle bought its Sun Microsystems. Its syntax is more similar to C and C++ than Python. It has so many versions. I don't know why they are doing it. Like almost every year, they come up with a new version. Now, the current version is 24. When I was teaching this course last semester, it was 23. And when I had first started teaching this course in 2018, it was, I think, Java 18. When I was learning Java, I was also in undergraduate, I was also learned Java, I learned also Java, and its version, I don't remember, but maybe Java 4 or 5. The problem is that they make really huge changes in some versions. So some things that we explain in Java will not be true for some other versions of Java. So this is, again, a challenge. But for simplicity, I mean, Java is really big changes. My explanations will be mostly true for the Java versions from 8 to 18. Okay, these are mostly maybe, I don't think that these are very common, the Java 22 or 24, okay? But when you are studying also, please check your Java version, okay? Especially when we come to the interfaces and so on, it is the things that something I will say will not be true. Like I said that Java is object-oriented, or every code needs to be a class. This was true until like maybe 2 years ago. But now it's in latest version, it is not. But since this course is about object-oriented programming, I'm saying that, okay, my teaching will be correct for the Java 8 to 18, okay? So you can also use these versions. It's very popular. Billions of devices, millions of developers have it. So the principles of Java is simple, object-oriented, familiar, robust, secure, architecture neutral, I will talk about it, portable, with high performance, and must be interpreted, threaded computation, and dynamic. So just to give an example, why it should be architecture neutral? Well, this is one good feature of Java. You don't need to compile a Java code differently for, I don't know, Linux or so on and so. It is actually an architecture neutral model. That's why when you are developing an application, it might be it will be better for you because you don't know which architectures your customers are using. Is it Java? Is it Microsoft? Is it Linux? And so on and so. It might be all different, but Java does not have that kind of a problem. And what you can do with the applications, like almost everything, like mobile applications, graphical user interfaces, web-based applications, enterprise scientific game applications, almost everything can be done with Java. And we use the software we use to write the Java program is Java Development Kit, or JDK. So in order to run programs on your computer, you have to install JDK. Then you will be able to run any Java, and it's free. You can just download it from java.oracle.com. And it has editions, like standard edition will be enough for this course and most of the applications. But for the large-scale applications, if you want some support for the distributed networking applications, then yes, you might need Enterprise Edition. Or if you have resource-constrained embedded devices, what does it mean? Well, when you are developing an application for smartwatches or those kind of devices, you don't have huge, powerful RAM or, I don't know, a CPU and so on. So your resources are limited. For those devices, you can also go with Java Macro Edition. But again, for this course, standard edition will be fine. And for the Java development, have 5 cases: edit, compile, load, verify, execute. So now again, this is another difference from Python. In Python has this interpreter. What is interpreting languages? And what is a compiling languages? You know, is there anyone who knows that? Any idea?
I think I do.
Yes.
A compiler executes all lines of code together, but an interpreter executes each line of code alone.
Yes, exactly.
Yeah.
So in Python, let's say that you have a program that requires 100 lines. But what you can do is you can first write 10 lines of it and then execute it. And then the next 10 and then execute again, and so on and so on. But in Java, if you need a program that needs 100 lines of code, you have to first finish it, 100 lines. Then compile all of them together and then run it. So there's a difference in Python. Like in Java, we have this compiling step. But first, let's go with the editing part. So editing a file is basically, again now, writing your code, basically. You can, using any editor, you can write a Java code actually. Like, I mean, by any editor, I mean, even the notepad would be enough to create a Java file. What you only have to do is that you write your code and then change the extension of the file to .java, then that becomes a Java file. But of course, this notepad is not very helpful to read the code and so on. It is not helpful, so many people are using these integrated development environment softwares, which is like the most popular ones are Eclipse, IntelliJ IDEA, NetBeans, and so on. So you can use any of them. Well, I use Eclipse, and during the lectures I will also use Eclipse, but it's really up to you, whatever tools that you use. These tools are useful for you to find the syntax errors and so on, and helps you to run the program in a much easier way. But I want to make one more warning. When you are studying, especially object-oriented, these tools are too helpful. When you are practicing, they will immediately show you, okay, you are doing this mistake, you are doing that mistake, you are doing that mistake. This is good, but again, in the exam, you will not have these tools, okay? So when you are studying, don't rely on these tools. Please use it in simple notepad or so. And then I'm moving on. Let's say that we write our code and then created our file. Then what we have to do is, okay, we will save it to our hard disk. And then we will use a compiler. A compiler, the Java compiler, it will basically take our code and convert it to a bytecode. To do that, well, if you are using these tools, it's so easy. You just hit one button and then it will compile it. But if you are using a command prompt editor, if you are a Windows person, or if you are using map terminal, if you are using shell, Linux shell, and so on, you can also compile these documents by using this command. Let me show you actually with one example. So what I had one example before coming here. So this is, I need to zoom in. But I'm not able to zoom in. Let me change the font size then. Okay. I need to zoom in. I'm trying to find a zoom in option. Yeah. I see. I think I found it. Oh, it will take some time. I'm not able to do it with sorry. Let's make it a little bit bigger and bigger and maybe bigger and more bigger until it is readable by you. Okay, so I want to make it in this way. Let me make it here. Yeah, okay, and maybe bigger and maybe bigger. So what you can do is, now this is the shell of Mac. So if you are using Windows, you have command prompt and so on. So what you can do is, without using mouse, you can do everything by writing any code. And in that sense also, I had this file before. In that one, I have these two files, welcome.java. So I can look at this file. It is a very simple Java content. For now, we are not interested in its content, but what I want to compile this. Okay, I want to compile this. How I can do it? I want to make it even bigger, so that would be more readable. If I say javak, okay, this is the keyword, and then I give my Java file name, it will create a bytecode. What is that? It is this welcome.class file. This is. So it created this bytecode. Okay, now this is the executable part. Now I'm moving back to my slides. Compiled it. If there was any grammar error or so, it would warn me. Then what is the bytecodes? Well, the bytecode is actually are platform independent instructions. So as I said, that Java is an architecture neutral program language. So how it handles it is actually by this version. It doesn't immediately changes to your machine language of your computer. It first changes to bytecode. It's only for the Java, it is platform independent, so you can take that class file and use it in Mac or in other architectures, okay? But then what happens is, how it handles it, how it makes it this architecture neutralness, it has also Java virtual machine. When you install Java on your computer, you also install a Java virtual machine. So this virtual machine actually acts as if it's a separate computer. It simulates a computer so that it considers that it's like a virtual machine. It's like a computer by itself, so that and it hides all the details for you about the details of your operating system and so on. So that class files can actually run on the virtual machine, and then the virtual machine will handle the communication with the operating system. Now I have the class files, and what I will do is, if I write this Java welcome, for instance, in our case also, if I type this, then it will be invoked by this command, and it will get this welcome.class file, and then it will be to execute this application on that computer. Again, I'm going back to my terminal. if I say Java welcome, basically it will run the code. It was printing this, the value is 5. So I'm able to run this application. Probably this is the last time that I will show you terminal. Okay, this is just to show you that you can do anything with any notepad. You don't need any these kind of Eclipse and so on. But after that, I will use Eclipse later on. Okay, but just to show you that yes, we can use it even with the command prompts. We can execute these applications. Now, when we have this, now this part is it's loading a program into the memory. So we have that class file. It is a file, so which means that it is written actually not in the main memory. It is in the secondary file in our hard drive. So we have to load it. The JVM basically use a class loader and loads it to itself, and then it verifies your bytecode. So it doesn't immediately run it. It first checks, is your code harmful to this computer? It might be a virus or a malicious web program. Is it giving any damage to your system? So it checks whether it is secure enough to run the code. So it runs this verifier. If it passes that, then it executes your code. What is happening here is that then the bytecodes are then translated to machine language of your computer so that it can run, if it is Linux or Windows, whatever it is, it can run on that computer. So it is basically 5 steps. By using the text editor, you write your code, then Java compiler reads it and compiles it and produces a .class file. And then it is interpreted by the Java virtual machine, and it creates the program execution. So this is the 5 steps of Java development. I think I'll already talk about it. So portable means, again, this architecture neutral part. I develop one application on Java, and then it can be used on other computers without any recompilation, without any recompilation. This is the portability. So if I have a .class file, then the only thing that you need is Java virtual machine for Linux, for Mac, and for Windows, whatever it is. Then I can provide these bytecodes, and then what will happen is all these .class files, or each of these JVM files, will convert to its own program machine language by using .class files. So the developer does not need to worry about whether the users are using Windows or Mac or so. But the only thing that users should have the correct JVM, should install the JVM files, and then they can run it with those .class files. Do you have any questions so far? Now the types of errors. An error is called bug, as you know, when fixing a bug in a code is called debugging. We have 3 types of errors: syntax errors, runtime errors, and the logical errors. Now we will briefly see them. But before going that, so why do we say bug? Sounds weird actually. Bug means like an insect. There's a history behind that. The very first one is coming from Thomas Edison. In the 19th century, he finds a cockroach in its quadrax telegraph, which is causing a problem in the circuits. So actually, he developed a bug trap to address that issue. This is the first bugs cause a problem, but not in the computers. The first bug that is being used as a term was in 1947. Really, bug caused a problem in the machine, and you see the original node. The person who was taking care of it found the bug in the machine relays and tapped it on the notebook just as a node. Okay, I found the bug. It was causing the problem. So yeah, why do we say when there's an error, there's a bug? Because there's a history behind it. In the history, yes, there was actually a bug that caused a problem. That's why now then it became a terminology to say that, okay, when there's a bug, it means that, yeah, we have an error. So first, the syntax error. Well, it's the easiest error actually, because it means that grammatical error mistakes that you do when you're writing Java. So this part of error can be detected in compiler time. So when you try to compile your code, the compiler will say that, okay, this statement is incorrect. You missed semicolon, or you missed a curly bracket, and so on. So the compiler will tell you exactly that whether you obey the grammar rules of Java or not. And if you are using these tools like Eclipse and so on, they actually automatically check all your code before even compiling. They will show you that, okay, you are missing this, you are missing that, you are missing that. So even you don't with these tools, you don't even need to compile the code. They will immediately show it. But again, we say that we will use it a lot, like compile time. What does it mean? And actually, the things that we did before compilation. If I said, okay, this is a compile time error, it means that I didn't run the code yet, but I did a mistake with the other part. So this is a compile time error. This is a good error. It is easy to find, easy to fix. The other part is runtime error, which means that your program is grammatically correct. But when you are running the program, you did a mistake. It causes the program to be ended, to be killed. It doesn't continue. Well, what can it be? Well, maybe you are trying to divide by 0. So from a grammatical perspective, you can say it like any number, you can divide it by 0. Maybe you asked an input to the user, and then you use that value for the division, but then the user just give you some number, 0. So you attempted to divide by 0. Or you are trying to open a file, but it doesn't exist. Maybe it's been removed and so on. These are called runtime errors. So you can only find them. If you have written code, if you analyze it, you might notice that there might be, in some cases, it can work incorrectly. You might get a runtime error. But if this is not the case, you are not able to find it in compile time, which means compiler gives no error. It says, okay, this is fine, you can go. But then when you run the code, it fails. This is called runtime error. And the other one is, the last one is the logical error. So now this is the hardest error, the error that we really don't like. Because the code compiles, the code runs, and finishes successfully. It doesn't it's not being killed, it didn't happen. But the thing is, your result is incorrect. So there is a problem in your algorithm. So this is why we don't like it, because it is harder to detect. How can you detect it? Like, let's say that you have a product and you developed it, there's no compiler, you did your test, there's no runtime error, you did all your checks, even the user input 0, you are not using it for division, you are doing all your checks, and that is fine. But then you put it in the market that the customer says that, your results are wrong. It's not correct. There's a problem with your program. This is the hardest thing, because now you have to go over all the code. Okay, why did I do a mistake? Because you are not getting any error. This is the part. You have to go all through your algorithm, all your code, if there's any problem or so. Let's say that what it can be, let's say that you want to calculate a Fahrenheit temperature from a Celsius temperature. So by that, what you can do is you need to multiply it by 9 divided by 5, and then you have to add 32. But if you made a typo and if you just add 23, then yes, this is a logical error. And it is hard to find again, because you just need to be careful, double check your outputs, if it is your expected output or so, and it is harder to debug.